This is Elon Musk, the wealthiest man on the planet, recently becoming the first individual to reach $500 billion.
A historic financial milestone. Elon Musk,
the CEO, touched a net worth $500 billion.
But at this level of wealth, do you even care about money anymore? Or you begin to develop other plans in your mind? This is the insane story of why Elon Musk created 6 interconnected companies to achieve his final goal: conquering Mars. To understand Elon Musk's ultimate ambition, you have to understand the philosophy born from the pages of science fiction. Musk has repeatedly said that Isaac Asimov's classic Foundation series was fundamental to the creation of SpaceX.
I'm a big believer in Asimov's Foundation series, or the principle that I recommend reading the Foundation series. But
the series tells the story of a mathematician who predicts the collapse of a galactic empire and the subsequent 30,000-year dark age. He couldn't stop the fall, but he created a plan to shorten the period of barbarism to just 1,000 years. Musk sees a direct parallel to our time.
We don't know, but there's likely to be another dark ages, which it seems, my guess is there probably will be at some point, particularly if there's a third world war. Then we want to make sure that there's enough of a seed of human civilization somewhere else to bring civilization back.
See, this isn't just a business plan. He sees himself as an actor on a historical stage. It's not a portfolio of ambitious but disconnected companies. It's a single integrated machine designed for one purpose: moving humanity to another world, something that nobody has ever done before. But how all this started in the first place? Before SpaceX, Musk's first idea was to send a small robotic greenhouse to Mars. The goal wasn't scientific, it was to capture the public's imagination, hoping it would inspire an increase in NASA's budget. To do that, he needed a rocket, so in late October 2001, he went to Russia to buy refurbished intercontinental ballistic missiles. But the Russian space officials didn't take him seriously. After several trips where he was dismissed and reportedly even spat on, Musk had enough. The pivotal moment came on the flight home. Frustrated, he opened his spreadsheet and, using a first principles analysis, calculated that the raw materials for a rocket were a tiny fraction of the final price. He looked at the costs and realized he could build a rocket himself for a fraction of the price. From that single decision, a chain reaction started. Every company he founded since was a logical next step, solving the next problem that emerged from that first simple goal of putting a greenhouse on Mars. But to build that future, you first need a way to get there. The journey to Mars begins here. A company forged in the crucible of catastrophic failure. The early years of SpaceX were a brutal lesson in the unforgiving physics of rocketry. The first 3 launches of the Falcon 1 all ended in disaster. Flight 1 exploded just 25 seconds after liftoff due to a single corroded nut causing a fuel leak. Flight 2 spun out of control and its engine flamed out minutes before reaching orbit. Flight 3 saw the first stage collide with the second, destroying both. By this point, Musk was on the verge of personal bankruptcy, with enough money for one final attempt. On Sunday, September 28th, the 4th Falcon 1 lifted off. This time, everything worked. It became the first privately funded liquid propellant rocket to achieve Earth orbit, a milestone that saved the company and secured a critical NASA contract. If the Falcon family proved private spaceflight was possible, Starship was the vehicle designed to fulfill the company's ultimate purpose. It's a fully reusable super heavy lift launch system, and every major design choice is dictated by the logic of building a city on Mars. In a move that stunned the aerospace industry, Musk pivoted the vehicle's design from advanced carbon fiber to stainless steel. This genius choice was because of a secret in this material behavior. Certain steel alloys actually get stronger at the cryogenic temperatures of liquid fuel. Steel's high melting point drastically reduces the need for a heavy heat shield during re-entry. But the most important factor was cost. Carbon fiber costs around $200 per kilogram. In contrast, stainless steel costs less than $4, And that's not all. The engine that powers it, the Raptor, is another Mars-driven innovation. It's the first operational engine to use a highly efficient full-flow staged combustion cycle. But the key is actually its fuel, which is a balanced combination of liquid methane and liquid oxygen. While methane isn't the highest performing fuel for a rocket, it has a secret feature. The Martian atmosphere is over 95% carbon dioxide, and water ice is abundant beneath the surface. Using a chemical process, these resources can be used to create methane and oxygen to refuel a Starship for a return trip to Earth. But a ride to Mars is useless without the infrastructure to survive there. That's where Tesla comes in. See, Tesla is not just another car company. It's the research and development division for the two things a new civilization needs most: a robust energy grid and a capable workforce. Mars receives less than half the solar intensity of Earth and suffers from planet-encircling dust storms that can block out the sun for weeks. A colony requires a completely off-grid, scalable and reliable power system with massive energy storage, and Tesla's energy division is building exactly that. This is the Tesla Megapack, a utility-scale battery. It's designed to store energy from solar and dispatch it when needed. As a perfect real-world example for a Martian power grid, Tesla enabled a Hawaiian island to retire its last coal plant with this technology. Every solar roof and utility-scale battery farm that Tesla installs is a real-world test, refining the technology that will one day form the backbone of the Martian power grid. But even with all these advanced technologies, someone still has to build them. The first inhabitants of Mars won't be human, they'll be robotic. Musk has stated that the first uncrewed Starship missions will carry Tesla's Optimus humanoid robots as their primary payload. They are the robotic vanguard, tasked with deploying the initial infrastructure, solar arrays, landing pads, and habitats before any human sets foot on the planet. However, robotics experts have warned that the fine, abrasive, and electrostatically charged Martian dust could quickly infiltrate the robot's complex joints, turning it into a dead husk. Surviving the extreme cold, which plunges to minus 125 degrees Celsius, and the lack of air for cooling, requires a radical redesign far beyond its current capabilities. Yet with transportation, power, and labor accounted for, Musk still has to solve the most fundamental problem of all: where will everyone live? The answer comes from his most peculiar venture, one of his most unpopular companies, founded in 2016, the Boring Company. Its public mission is to solve urban traffic by digging low-cost tunnels, but Musk has been clear about its deeper purpose.
Yeah, actually, so I do think getting good at digging tunnels could be really helpful for Mars.
Life on the surface of Mars is untenable long-term. The planet has no magnetic field, and a paper-thin atmosphere offers no protection from a constant bombardment of lethal cosmic radiation. A permanent human presence must be built underground. The Martian soil, or regolith, provides a natural and powerful shield against both radiation and the brutal surface temperature swings. The Boring Company's goal is to dramatically increase tunneling speed and slash costs by a factor of 10 or more. But deploying this technology on another planet presents formidable unsolved challenges. Terrestrial tunnelers rely on vast quantities of water for cooling and lubrication. On Mars, water is a precious resource locked away as ice. The very heat from the machine could melt surrounding permafrost, which could then refreeze and trap the multi-ton machine in solid ice. Even with a place to live, a city on another world needs a connection to home, a financial lifeline to fund its creation, and a data link to exchange information. Starlink, SpaceX's satellite internet constellation, is designed to provide both. The core of the Starlink network is its optical inter-satellite links, or space lasers. Each satellite is equipped with lasers that create a high-bandwidth mesh network in orbit, routing data at nearly the speed of light. This operational large-scale laser communications network is the perfect real-world prototype that will be needed for an Earth-Mars communication system. But even with lasers, you can't beat the laws of physics. As Earth and Mars orbit the Sun, the distance between them means a one-way signal takes between 5 and 24 minutes to travel. A simple question and answer could take up to 48 minutes. Real-time communication is impossible. A Martian colony cannot rely on Earth for troubleshooting or decision-making. Any critical failure must be resolved autonomously. That profound communication lag creates the need for the final and most ambitious layer of the entire plan. If the physical infrastructure of Mars is built by SpaceX, Tesla, and the Boring Company, its cognitive and biological infrastructure falls to XAI and Neuralink. Launched in 2023, XAI's stated mission is to understand the true nature of the universe. Its practical purpose, however, is to solve the problem of the time delay. The Martian colony must be almost entirely autonomous. XAI's goal is to develop an artificial general intelligence capable of acting as the AI overmind for the entire settlement. An AGI would be required to holistically manage the colony's incredibly complex closed-loop life support, power grid, and robotic workforce. To achieve this, XAI has a unique advantage: access to vast proprietary datasets from the physical world, including vision and control data from millions of Tesla vehicles and operations data from SpaceX, providing an unparalleled training ground for its AI models. You can see the power of these valuable data sources in how much better Tesla's autonomous driving has become with recent updates. While XAI is designed to manage the hardware, Neuralink is focused on the wetware, the human brain. Long-duration spaceflight is profoundly damaging. Astronauts suffer from cognitive impairments, anxiety, depression, and even structural changes in the brain. In the near term, a brain-computer interface like Neuralink's could serve as a high-fidelity check engine light for the brain, monitoring an astronaut's cognitive state in real time. But Musk's ultimate goal is far more ambitious. His goal is to merge the human brain with computers. On Mars, this transhumanist vision becomes a tool for adaptation, allowing colonists to seamlessly interface with the colony's AI, control complex machinery, and access vast amounts of information instantly. The plan, when synthesized, is breathtaking. Starship provides the transport. Tesla robots arrive first, deploying Tesla power systems to create a grid. Guided by an AI from XAI, they use Boring Company technology to build subterranean habitats. The entire endeavor is funded by Starlink, which also prototypes the communications network, and Neuralink offers a path to help humans survive and adapt. Is this the next giant leap for mankind, or is it the ultimate act of technological hubris, a dangerous delusion pursued by a man seeking to escape the very world he has the power to help save? The answer remains unwritten, waiting on the silent red horizon of Mars.